Okay, so we're going to look at an example of normal distributions. It says heights of 10-year-old girls are normally distributed with a mean of 138 centimeters and a standard deviation of 7 centimeters. A 10-year-old girl is chosen at random. Find the following. So we have a normal distribution, which is a continuous random variable, and I've drawn it in here. The center of the distribution is always the mean, so 138. I'm going to write down the mu is 138 and the standard deviation sigma is 7. So write that down, and then the first part we're trying to find the probability she is shorter than 120 centimeters. So the probability that she is shorter than 120 centimeters, that's the probability that x is less than 120. And that would be represented by the area to the left of 120 in the picture. So in the picture, we're going to go over there and figure out where 120 would be. So each of these tick marks would represent one standard deviation away. So the standard deviation is 7, so that would, I need to go to the left. This would be 131. If I subtracted 7 from 131, that would be 124. Remember, all of the data is going to occur within 3 standard deviations of the mean. So we're looking for 120. So it's actually even farther over than that second tick mark. We want everything to the left of that. So that's going to be this area over here. And it doesn't look like it's very much, but we're going to jump over to Excel. So that, and just you should probably label that on my picture as well. That's 120. I'll jump behind here to Excel, and I'm going to type in normal distribution. So in here, equals norm dot distribution. So I can just type norm and all the normal functions will show up. There it is, double click on it, and then it tells you what you want. It wants the x value, which in this case is the 120. It wants the mean, which is 138. It wants the standard deviation, which is 7. And it wants to know the cumulative. And this will be the cumulative area from the left. So Excel will always give us the areas to the left of the value. Cumulative areas to the left. Tab out. 0.0051. Generally, we round these probabilities to 4 decimal places, which I've already done here. Okay, so the next part wants the probability that she is taller than 145 centimeters. And that's the probability that x is bigger than 145. So that's going to be an area to the right of 145. And if I want to draw that in my picture, 145, well, if I add 7 to 138, that's 145. So it's 1 standard deviation above the mean right here. And I'm looking for the probability that x is bigger than that. So I draw a line in at 145 and shade this area to the right. The technology Excel that we have will only tell us the areas to the left, the cumulative areas to the left. So we have to convert this problem. So remember that the total area under this curve would be 1 because the sum of all the probabilities has to equal 1. So the way we're going to figure out the area to the right of 145 is we're going to take the total area and subtract off the area to the left of 145. And we can do all of that in Excel. I suppose in the picture, you know, we still want the area to the right. I don't really want to change the picture, but we're subtracting off this white area, which is this normal distribution where x is 145, the mean is 138, standard deviation is 7, and the cumulative value is true. So we want 1 minus all that. And again, I can type all that into Excel. So equals 1, I can do 1.0 minus norm.distribution, 145 is the x value, 138, 7, and and the cumulative option is true. So I type that all into Excel. I don't need to compute that area to the left, because I really want 1 minus that area. Tab it over, and 0.1587, which I've already typed in, or about 16% is the probability. So the next example is dealing with the probability that she is exactly 140 centimeters tall. That's the probability that x equals 140. And if we remember from our uniform distributions, any continuous probability distribution, so 140 would be about here. But I'm not shading any area because I'm not going to the left or to the right. I'm looking at the value when x actually equals 140. That has to equal 0 because there is no area there. So remember, from a continuous distribution, the probability that x equals something has to be 0. If you think about why that would be the case, again, if it was something other than 0, we would have infinitely many places where the probability was not 0, and when you add those all up, it would be bigger than 1. Okay, so that answer is 0. The next problem is looking at a probability that, look, I skipped a page. She is between 125 and 145 centimeters tall. And in this example, I can put the x values between the smaller 125 and the larger 145 values. So, again, in the picture, I can draw that, and 125, let's see, minus 7 would be 131, minus 7 against 124, so 125 is about here, just above that second standard deviation below, and 145 is 138 plus 7, so that's up here at this first standard deviation above, and we're looking for the area between these two values. Someone's honking outside. And that area between them is here in the picture. It's really good to have a picture because it always tells you sort of what we think the value should be. And part of that is drawing a representative picture. The 3 tick marks, by the time you land over in the tail, by the time you're over, you should be hitting the 3rd tick mark as you get over into your tail. So from the mean, 1, 2, 3 standard deviations away, 1, 2, 3 standard deviations away in both directions, kind of land us over in the tails. So because Excel can only find the areas to the left, we have to convert this problem. And what we do is we think of it as, if I took everything to the left of 145, so from here down, the area to the left of that, we'd have this little bit extra down here to the left of 125. So the area in the middle is everything to the left of 145 minus everything to the left of 125. And we end up, when we do that subtraction, with the stuff in between the two things. If you wanted to write it in terms of probability, it's probability that x is less than 145 minus the probability that x is less than 125. We don't really need that step because we can go right to Excel and say, okay, so the probability that it's less than 145, that's a normal distribution. The x value is 145, the mean is 138, the standard deviation is 7, cumulative value is true, and then minusing off the normal distribution, 125 being the x value, 138, standard deviation 7, cumulative value is true. I'm just going to do that over here again in Excel. What I might do in this case is type the first one in, 145, 138, 7, and true, comma, true. And usually I click on this true because it gets me in all caps there. I might do that first one and then copy it. and then go up above here and subtract it off. Paste it in, and then change the second value of 145 to 125. So you can see upstairs here what I have typed in into my formula bar. If you don't have your formula bar, you can click on this FX thing and it should show you, or you can go up to View. I'm not sure about that yet. Come ask me, I'll help you find it. If you need help finding it. Okay, so we'll tab out of there, or you can email me. Tab out of there, 0.0897 or 81%. And you know, if we look at the picture, that looks like that could be a reasonable answer, 81%. 81% of the area is shaded. One thing to think about in these pictures is, you know, the mean is halfway in the middle. So if, you know, what's the probability that you're less than the mean? Well, if you divide this in half, it'd be 50%. So each half of this graph is 50%. We have this symmetric normal distribution where the data is split evenly on either side of the mean. So that helps us figure out, you know, if we go back up for a second, this one being 15%, you know, everything to the right of 138 is 50%. So it kind of makes sense that, you know, there's a bigger chunk of area here between 138 and 145 than there is between 145 and forever in the other direction. Okay. Sometimes that's hard to tell if your graph is not if your graph is not the right shape. So one thing about these graphs is that the tails, the ends, they should come down and get closer to the axes, but never quite touch. So they get closer and closer and closer, but they never quite touch that axis. And those actually go on forever. But there's very little data outside of 3 standard deviations. There's basically no data. So, okay, the next part says what height represents the 80th percentile. So this is something different. Now we're looking for the x value. I want to know what x value corresponds with the 80th percentile. Well, remember what the 80th percentile means. The 80th percentile is the height where 80% of the data lies below it. So in our picture, I want to draw that percentile here, and then I'm estimating. So I'm just going to say, okay, maybe right here, shade that in. This area has to be 80%. Remember, the total area is 100%. So we want the place along this x-axis where 80% of the heights lie below it. That's what the 80th percentile means. And we can look at this. We can see it has to be bigger than 138 because, I mean, we don't know if it's bigger or smaller than one standard deviation away. I don't know that until I plug it into Excel. In Excel, we're going to use a different function, norm.inverse, or the inverse norm. So I'm going to go to Excel. It's basically going backwards. You know the percent to the left, and you want to find the data value that's associated with it. So equals norm.inverse, and then it wants the percentage or the probability. So that's 80%. So I have to enter that in as a decimal, 0.80. That number always has to be between 0 and 1. If not, you're going to get an error. So if I put 80 there without the decimal, it's going to give me an error. 138, and that's a really common mistake. And then 7, and then tab. It's 143.89. So I rounded it to the nearest tenth and put 143.9. I think on the WAMAP homework it says rounded to the nearest centimeter, so that would be 144 centimeters. So 80% of the 10-year-old girls are shorter than 143.9 centimeters. Okay, and then the last part is asking about kind of the same question, but in a slightly different manner. It says, what height would put someone in the tallest 1%? So you have to be kind of careful here, because now the 1%, it would be the area to the right of the value, not the area to the left. And Excel always gives me cumulative areas to the left. So if we are looking for an area to the right of this value of 1%, that would leave another 99% area to the left. So what we're really looking for is the 99th percentile to find the tallest 1%. Or in the picture, over here is P99. There's 1% of the area above it and 99% of the area below it. So when we go over to use Excel, again, we're using norm.inverse, but we're not typing in 0.001, we're typing in 0.99, the area to the left. And then 138 and 7, and we get 154.3 centimeters. Just double check that, typing it into Excel equals norm.inverse. Because we're going backwards, 0.99. Make myself small maybe. 0.99, comma 138, comma 7. That's the mean and the standard deviation. Again, inside the function, it will tell you what each piece should be: probability, mean, standard deviation. Tab out of there, 154.3 centimeters. Okay, so that is our example on normal distributions. Couple things you want to take note of, just in general, would be, if I go back up to the beginning, Excel has two functions that we're using, normal dot distribution, and that always gives us an area to the left of the value. If we need an area to the right, we draw that, but then we look at it as, everything, or 1.0 minus that area to the left. So you can enter that all into Excel, but whether you use the 1 minus it or just the thing itself depends on whether you want the area to the left or the area to the right. When we talk about the probability of a certain particular value, so that x equals something, that always has to just equal 0. I could write it in 4 decimal places, but I'll just write it with a 0 as well. Another way we can use norm.distribution is to get between two values. So the probability that x is between two values, again, we have to do it in terms of areas to the left. So it's normal distribution from the larger value minus the normal distribution from the smaller value. And again, these are cumulative, so it's everything to the left of 145 minus everything to the left of 125. So those are the ways to use normal dot distribution. And then we have inverse norm, and then for the inverse norm or norm dot inverse, again, it's the same condition where the percentage that we type in is always the area or the probability to the left. So when we're looking for a percentile, that is the value, 0.80. But when we're looking for some top percent or the tallest 1%, then we have to take 1 minus the 1%, or 99% is the area on the left. Okay, hopefully that helps, and good luck. That assignment for normal distributions is very similar to what we're going to be doing in the next chapter, chapter 7. The difference is, in these examples, we're taking a single person. Up here, we chose a 10-year-old girl at random. And when we switch over to chapter 7, we'll be looking at choosing a sample of 10-year-old girls, so a set of people. Okay, but we'll worry about that later.